I'm not going to list them out, but how to find a side or an angle. But the huge issue is great techniques to find a side or an angle, but only works if I'm working with the what? Right triangle. And honestly, how many times am I going to have a right triangle thrown in front of me? Probably less than 10% of the time. So there's got to be something else with just any type of triangle. All right, what if it's not a right triangle and I want to find the side and the angle? That's going to be today and the Monday we get back from break. All right, that's the last part of this unit is, hey, the triangle's not a right triangle anymore, but I'm still asking for a side or angle. What the heck do I do? All right. First thing, before we hop into example one, you're going to see some new notation I want to expose you to right now. All right, we are used to this side right here being called AB. We call that side AB. Now, though, starting today and the rest of the unit, instead of calling that side AB, it's going to be referred to sometimes as side C, lowercase c. Why do we pick it as lowercase c? What's it across from? Angle C. All right, so instead of side AC, you're going to see it referred to as side B. All right, so get used to that new notation. If you see a lowercase letter, like you see, like if I have A equals 12, that's telling you the side across from angle A is 12. All right, so some new notation coming at you. New notation. All right, take a look at my first example here. We're just going to throw you right into the fire. Not your favorite, but my favorite direction. Solve this triangle. All right, solve this triangle for me, which means to us, find all the missing angles and find all the missing sides. Hey, first, why don't we do something we know how to do? How many angles did I give you? 2, so you can definitely find the third, right? Let's start there. All right, let's find the third angle. Angle C, we definitely have enough information to find the third angle. I don't need to teach you anything new there. And when you're ready, that third angle, Vinny, when you're ready, 30 degrees, good work. That's 30. If you want to plug it in too, go ahead, 30 degrees. All right, now we come to the sides we have to find. And we got a problem, don't we? Is this a right triangle? All right, so we have no idea. All right, Hill-Sass, 30-60, sine, cosine, tangent. Can't use anything we've used so far in the first 11 days of this unit. It's not a right triangle. So what do I do now? I'm going to introduce to you a technique today that can be used on any type of triangle, including a right triangle, any type to find a side or an angle. It's called, up top, law of sines. All right, it's called the law of sines. This can be used to find a side or an angle in any type of triangle, including a right triangle. And what the law of sines is, it's a proportion. All right, it's a proportion. So let's start by finding side A here. We're going to find side A, which means the side across from angle A. All right, it's already labeled in your diagram. The law of sines is a proportion. Okay, it is a proportion. Here's what it says. You take a side length. You take a side length. So we're going to do side A. Okay, side A, the one we're looking for. Underneath it, you put the angle across from it. What angle is across from side A? I know it's angle A, but how many degrees is it? Everyone see it? It's 110 degrees. But I don't put 110. This is the law of sines. I put the sine of that angle, 110. So it's the side across from the sine of the angle across from it. What's going to go here? Same exact thing. A side and the sine of the angle across from it. But do I really want to introduce a new variable? Probably not. So why don't you give me a side that we know and an angle across that we know? So what side was given to us? 28. So I'm going to put 28, a side length, over the sine of the angle across. And what's the angle across from it? 40, but I don't put 40. It's sine 40. All right, here is the law of sines. Side over the sine of the angle across from it. And the same thing goes here. How have we been solving proportions all year long? Cross multiply. I'm not changing the rules here now. All right, let's cross multiply. So we have sine of 40 times side A equals 28 times the sine of 110. All I did was cross multiply. We're looking for side A. Don't overthink this. This is the same thing we used to do when we solve for sides using SOHCAHTOA. How do I get A by itself? Divide by sine 40. Not just 40, sine 40. Divide both sides by the sine of 40. And now I just go to my calculator now, right? 28 times the sine of 110 divided by sine of 40. And then go back to your directions. What am I looking at here? Nearest tenth? When you have that value rounded correctly, let me know. Take your time though. Vinny, 2 for 2. Good job, 40.9. All right, and that was for side A, 40.9. We haven't solved this triangle yet, have we? Right? We still have a missing side. We still got a missing side. So we got to find side C. Incorrect statement. Why? Oh, let's do Pythagorean theorem. Not a right triangle. Sorry. It's not. Can't use it anymore unless it's a right triangle. So here we go. Law of sines again. There's nothing I've taught you in this unit that can find that missing side other than what's here now, law of sines. So why don't we start with side C now? What am I going to put side C over? See if we're picking this up yet. C over, Micaiah, should I put it over? What's the angle across? 30, right? So sine 30. Make sure, everyone, that's my one concern. We're going to forget the sine. Sine of 30. Now, over here, we have a choice. We just found the 40.9, but just like we showed before, you got to use the unrounded answer. For me, I just stick with what was given. I'm going to stick with the 28 and the sine 40. Again, if you want to use the 40.9, it's got to be the unrounded version. All right, if you're going to use that. All right, nice little proportion there. Let's cross multiply. So I got sine of 40 times C equals sine of 30 times 28. Yeah.
When we're cross multiplying, could we write that as sine of 40 times C equals 14, or do we have to use sine 30 times 40?
No, you could say, yeah, you can multiply it out and write that. But if, again, Billy, remember, if it does, like, this is nice because it comes out to be just 14, but if it comes out to be a decimal, we got to write the whole thing out. All right, don't try to round it. Yep, that's fine. And what are we looking at here again? Nearest 10th, before I move on here, nearest 10th. Jared?
21.
Yes, good work. All right, don't go on to the next one. I just want to show you something real quick. All right, anytime you have a problem where you need to solve a triangle, and you can kind of take, at the end, you can take a look and see if you're pretty confident you got it right. I really don't know if these values are, I know they're correct because we did it together, but you're doing a test or a quiz or a homework assignment. Are these values actually correct? Here's a way you can tell. Back before the midterm, I had given you guys a triangle fact. Where's the smallest side always should be located? And where's about the biggest side? So that fact should match your diagram. Okay, that fact, after you're done solving a triangle, take a look at it and see if that is true. Is the biggest side across from the biggest angle? Is the smallest side across from the smallest angle? If it is, you can be pretty confident. Again, this works in a right triangle too. All right, you can do sine of 90 degrees. All right, this works in a right triangle if you ever have it. All right, a couple more here. Good news, you don't have to solve for a triangle anymore, just a certain part of it. So I'll let you guys get this one set up on your own, triangle DAT. And everyone starts noticing I'm using the new notation now. I'm saying side T. I'm not using DA, I'm using side T, which means the angle across from T, 21. And I'm asking everybody to find side D. Side D, the angle across from angle D. The side across from angle D. Before we start, everyone have that triangle set up. Everyone have that triangle set up. I wait all year for this. Does everyone have that triangle set up? We're good? Got it? That triangle, anybody? We're good? Drew, you get it, right? Yep. Talk to your group about it, all right? I wait all year for this. Yep. And I get nothing. Yep. Dat triangle. DAT, everybody. Dat triangle. All right. Maybe some of you are still lost, but talk to your group members. Talk to your group members. Maybe you'll understand it after break, maybe, or during break. All right, we ready? Moving on. Law of sines, because this is not a right triangle, so I got to use law of sines. Looking for side D. What should I put it over now? D over. What's going to go on the denominator there? Not Bailey.
48. Sine 48.
Where's 48 coming?
Oh, no, I'm sorry. I was on the other side. Sine 27.
Sine 27. Good. Sine 27. All right, we come into a slight problem, but I think you guys can handle it. The only other side I know is 21. But I'm not putting that over sine of 105 because it's the only angle left. I have to put it over the sine of the angle across from it, which is angle T, which is missing. I prefer not to put a different variable. How can you find angle T for me? You have enough information to find it. Finley, how you find an angle T? There we go. You know how to find it. And what are we looking at for that one? 48 degrees. All right, there you go. Now you can plug in sine 48, not 48, sine 48. Go ahead, cross them up. And we're dividing by sine of 48 on this one. Oh boy, here these rounding directions on you. What does nearest integer mean, Mr. Carlino? That means a whole number, everybody. Positive or negative whole number is an integer. But probably not going to be a negative, right? So it's rounding to the nearest whole number. When you have that number, let me know. Jonathan, when you have it, let me know. 13. Look at that. Yep. Number comes up as the answer. All right, we good. All right, now for something to end it. Something special now. We've solved for sides. Can I use law of sines to find an angle? You're darn right I can. Hold on, though. Whoa. Before you even set up anything, I want to go back to when you used SOHCAHTOA for the quiz yesterday. When you used SOHCAHTOA and you were finding an angle, when you found an angle, what was so special that you had to do at the end of the problem? Because remember, when you found an angle, no cross multiplying. What was so special that we had to do at the end of the problem? Had to hit the shift button. We're going to find an angle here. So guess what we're going to have to do at the end? Shift button. All right. The rules don't change. All right. At the end of this problem, we're going to have to go shift, probably sign, right? Shift, sign, and then type something in. So keep that in mind. If you find an angle, it's the shift button. All right. Let's set this up now. Angle C, $1.12. C is 10, which means the side across from C is 10. Side across from B is 7. What's angle B now? All right, solving for an angle. What is angle B? All right, help me with the law of sines. Ready? Let's start with a side and an angle we know. Side and angle relationship we know. 10 over sine 112. No issues there, right? All right, next, what about another side that we know? 7. Now I'm interested to see. What are you going to put below that? What are we going to put below that now? Okay, I'm just not going to put x, right? What have we been putting down below? Sine of it, right? So you can put sine x, or for me, because it's angle B, I'm going to call it sine of B. But you can just don't put x by itself. Got to have the sign with it. Got to have the sign. All right, I'm going to take our time now solving this because it's a little bit different at the end like we talked. So here we go. 10 times sine B. So I got 10 times sine of B equals, cross multiply the other two here, 7 times the sine of 112. All right, so there's the cross multiplication done. Remember, I'm looking for angle B, but before I get to angle B, I need sine B by itself. All right, I need to get sine B by itself. So how do I remove the 10? Divide it out. So I have sine of B by itself equal to, now everyone's going to the calcs, and so will I. See what this is going to equal. I forgot it already, of course. 7 times 112. Divided by 10. I'm only concerned about the decimal. All right, we're concerned about the decimal. I don't care what it reduces it to, just the decimal here. Now I want to talk about how a common sense check here. So 0.6490286982. That's not angle B. All right, I'm never going to give you a problem where it's less than a degree, the angle measure. Right, that's not it. That's what sine B is equal to. Now I know some of you are getting probably a little confused, and I get it, because when we did SOHCAHTOA, this used to be a fraction, like 2/3, 6/8. This used to be a fraction instead of a decimal, but the rules don't change. What did we just talk about? At the end of this problem, what am I going to have to do? Shift button, right? And this is where we do it, right here. All right? And sine of B is equal to this decimal. So if you want angle B, we're going to have to do what comes up as arc sine on your calculator. So we go back to the calculator. All right, I got the sine of B. Now it's time for shift sine. And I plug in my decimal. Because remember, you guys used to plug in a ratio, right? A fraction. But now it's just as a decimal instead. All right, you guys can retype it. You can hit the answer button. Copy paste if you want it. All right, I know you guys are so used to doing it as a ratio or a fraction. Well, now it's in decimal form. And there it is. Boom. Now I just got to round it to the nearest, what is it, degree. So angle B, 40 degrees. And that makes sense because it better be less than 112 because 7's less than 10. Smaller side across from smaller angle. All right, so please, listen to me, I am never going to give you a problem where the answer comes out to be less than a degree. All right, so that should get in your mind, oh, whoa, I've got a shift button here. All right, let's roll. Let's go. Get it out. The more time and effort you put in, the less work you got to do over break, if anything.